Welcome friends. We are discussing now AC fundamentals. Now let us solve some numerical problems on the topics what we have discussed till now on AC fundamentals. Let us go. So consider figure 4. Consider figure 4. We have a figure. Now what is the average value and RMS value that is of the waveform shown in figure 4? We need to evaluate average value and RMS value. So first we have first we have something like stair like structure, and then we have a constant value. So from the stair level, ramp like structure is existing between time 0 to 1 second, and this constant value 100 ampere is staying from 1 to 2 ampere. So we can write I, if it is a I current IT, then it will be 100 T. This is true for 0 less than t less than 1 second, and then it will be is equal to 100 ampere. It is true for 1 less than t less than 2 seconds. So if you represent the whole wave, it should be added. So that is the exactly thing we have written. It is equal to 100t and plus 100. Now ut minus u1, it is called a gate function. It is called gate function. We shall come later on, later of this course, the significance of the gate function. For the time being, let us consider only this is 100. It will not make any difference. So it is equal to 100t plus 100. Now why this is 100? Because you need to evaluate the slope of this ramp. You need to evaluate the slope of this ramp. What is the slope? Slope is the change of y. This is 0. This is change of y. That means it is 0 to 100. So 100 minus 0, that is the dy, and dx, that is the change of x. Change of x is 0 to 1. So 1 minus 0. So 100 minus 1 is 100. So slope becomes 100. So what is the average value? So average value is nothing but 100t plus 100 dt. You integrate it from 0 to so you need to write separately. So when you are integrating 100t, your integration limit from 0 to 1. However, when are you integrating 100, your integration limit from 1 to 2, because this is the equation. So when now you two should take the average value, so you need to divide the summation with the entire time duration, that is 2 seconds. So that is why it is written 1 by 2. So it will be now 100t, integration is 100t square by 2. If you put limit 1 to 0, it will give you a value of 50 into 1 square, because 100 by 2 is 50 and t square is 1 square, and this half is 0.5. And if you integrate 100t, if you integrate 100 from 1 to 2, so it will give you a result 100t. So if you put limit 2 to 1, so it will give you 100 into 2 minus 1, that is 1. So if you solve this, it will giving you the result average value as 75 ampere. Now when you are calculating the RMS value, you need to first square it. So I square t. So let us first square it. So 100 square t square. So you should integrate from 0 to 1. Then you should square 100 square. Then you should integrate from 1 to 2. Now you need to take the square root. Then you need to take the square root at the end. So it is in the outside we have 1 by root 2. Now 100 square t square, if you integrate, then it will be is equal to 10,000 into t cube by 3, because t square integration is t cube by 3, and 100 square dt, that means equal to 10,000 t. So if you put the limit appropriately, it will give you the result like this. 10,000 by 3, this is 3,000, this value, and it will be t cube. If you put the limit 1 to 0, so it will be 1 cube, and 10,000 into 2 minus 1, so 10,000 into 1, so 0.707, which comes from 1 by root 2, which comes from 1 by root 2. 1 by root 2 is 1.707, so if you multiply it with this, it will give you 80.64 ampere. So for the same wave, the average value comes out to be 75 ampere and RMS value comes out to be 80.64 ampere. Now let us move to the next problem, which is this. Evaluate E1 plus E2 plus E3. Some EMFs are there. So E1 is there, it is written 100 sin omega t plus 60 degrees. So from the phasor notation, we can represent this one as 100, that is the magnitude, but you see omega t, sin omega t is the reference. Now it is representing plus 60 degree. It is representing plus 60 degree. That means it is a leading phasor. So we can simply write E1 is equal to 160 degree. So E1 is equal to 160 degree. That is written. Similarly, if we consider E2, now it is magnitude is 50. We have written 50. However, it is sin omega t minus 30 degree. So it is the lagging phasor by an angle of 30. So we should write 50 minus 30 degree. So E2 is written 50 minus 30 degree. And thirdly, E3 is written 125 sin omega t minus 75 degree. So 125 is the amplitude. 120. It is not a reference. It is neither a reference nor a leading, because it is the negative angle. So it is lagging by an angle of minus 75 degree. So E3 is written as 125 minus 75. So what we are getting, E1 is equal to 60 degree. Now E2 is equal to 50 minus 30 degree, and E3 is equal to 125 minus 75 degree. So these are the three phasor notation, phasor representation. Now if you add these three, E, so the answer should not be 100 plus 50 plus 75, which is equal to 225. No, absolutely no. It is totally wrong, because the phasor summation is not at all same with the algebraic summation. Phasor summation is not same with that of algebraic summation. Here this angles plays a very important role. Here angles plays a very important role. How? Now let us say if you have a complex number, let us say I have a complex number x, its magnitude is xm and angle is theta. So it can be expanded in this way, xm cos theta plus j sin theta. On the other hand, if we have another phasor like this y, its magnitude is ym and angle is minus theta, then it can be expanded in this manner, ym cos theta minus j sin theta. So you have a cos theta value, you have a cos theta value, you have a sin theta value. Accordingly, you will get a phasor notation. So if you look, if you break this one just mentioned in this figure, so 160 degree it is written, 160 degree it is written cos 60 plus j sin 60. Now cos 60 is 0.5. So 100 into 0.5 is 50 and sin 60 is 0.866. 0.866. So 100 into 0.866 is equal to 86.6. So E1 is equal to 50 plus J 86.6. This is the result. Now similarly, what about E2? Now E2 is equal to magnitude 50. Now this angle is minus 30 degrees. So follow this. So it is cos 30 minus j sin 30. Cos 30 minus j sin 30. So cos 30, you know, root 3 by 2, that is 0.866. So it will be 43.3. And sin 30 is 0.5. So it will be minus 25. So this is actually this 43.3 minus j 25. Similarly, E3 is same, cos 75 minus j 75. Because this is a negative angle, if you solve this, if you expand, it will giving you this result. Now you can add this. Once you have this form, Cartesian form, you can add them. 50 plus j 86.6, then 43.3 minus j 25, and 32.4 minus j 120.7. In this form, you can add this. If you add them, it will give you a result of 125.7 minus 59.1. Now, if you have a polar quantity, let us say, if you have a quantity like simple, so let us say if you have a 2 angle 30 degree, have a something like this, let us say 2 plus j3. What will be its equivalent polar coordinate or polar representation? Its magnitude is very easy, 2 square plus 3 square. Now the angle is nothing but tan inverse 3 by 2. So this angle is nothing but tan inverse of minus 59.1 by 1.7. So it will be coming out to be minus 25.2 degree. Now I want to make a mention few more aspects, that suppose we have 2 minus j3 minus 2 plus j3 and minus 2 minus j3. For these 4 numbers, 4 complex numbers, 4 Cartesian forms, the all magnitudes are same. 2 square minus 3 square. Magnitudes are all same. Here minus 2 square plus 3 square. Lastly, we have minus 2 whole square plus minus 3 whole square. So magnitudes are all same. Now if you evaluate the angle, you see this, the fourth one, it will be tan inverse minus 3 by minus 2. So they will give you the same result, but which is not true. The meaning, you see, if I draw a plane, this x-axis represent real and y-axis represent imaginary, then 2 plus j3, it stays in the first quadrant because its real part is positive, imaginary part is also positive. So evaluated angle should lie between in this angle, this first quadrant, right? The evaluated angle should be lie in the first quadrant. Why? Because this 2 plus j3 stays in this quadrant because real part is positive, imaginary part is also positive. Now if you consider the second one, 2 minus j3, here you see 2, that means it is the real part. 2 is the real part is positive, but imaginary part is negative, real part is positive, but imaginary part is negative, so it stays in the fourth quadrant. So its evaluated theta should be lie between 270 360, or in some other way it can stay from 0 minus 90. Sorry, it should be greater than. It should be greater than. Now if you consider the third one, minus 2 minus j3, minus 2 plus j3, so its real part minus 2 plus j3, so its real part is negative, real part is negative, but imaginary part is positive, so it stays in the second quadrant. So its evaluated angle should be lie in this region, 180 greater than theta greater than 90. So it stays between 90 to 180. And lastly, minus 2 minus j3 stays in the fourth quadrant, third quadrant, sorry, minus 2 minus j3, it stays in the third quadrant, because all the real and imaginary part all are negative. So you know, in the first quadrant all are positive, in the second quadrant only sine terms are positive, in the third quadrant tan are positive, and fourth quadrant in cos are positive. So since you are evaluating tan, so it will give you a positive result, but which is not true. Its theta should be lie between 180 to 270. This should be the range. So similarly, so if you evaluate this, it will be coming out to be minus 25.2 degree. Now how you can represent? Now you see this line. This line is reference. What is E1? E1 is 100, but it is a leading phasor. So magnitude is not much important. So this angle is 60 degree. It is the leading phasor. What is E2? E2 is a lagging. So this angle is 30 degree. That is the blue curve. Lagging. And what is E3? It is a lagging further by an 75 degree than the reference. So it is the 75 degree. And if you add these three, you see the net phasor is located something here, making an angle of minus 25.2 degree with the reference. So basically, but the magnitude is also see totally different, 138.9. So if you opt for algebraic summation, it should be 225, but it is totally wrong. The correct sum is this. So if you have polar form, if you have a polar form, that means this form x theta, you should always opt multiplication and division. And if you have a Cartesian form, if you have Cartesian form, that means a plus jb, in this form you should always opt for plus and minus. This is the normal rule. That means if you encounter this polar form like this, if you encounter polar form like this, you cannot do plus or minus operation. You first need to convert them into Cartesian form, then you need to do. On the contrary, if you have a Cartesian form like this, it is better not to do product or division. First you convert it to the polar form, then do the multiplication or division. It will be easier. Now moving on to the next problem, let us consider this one. It is this wave. This voltage wave, or this wave particularly, is typically represent full wave rectified sine wave. So it should be represented by this equation: Vt is equal to Vm sin omega t d omega t. Omega is from 0 to pi, because it is no meaning of writing pi to 2 pi, because pi to 2 pi it is not negative, so it is staying, or it is valid only in between 0 to pi. So then you should calculate the average value. Average value is what? Vm sin omega t d omega t. Now the integration should be carried out from 0 to pi, and average value, then you should divide the entire summation by 1 by pi. So sine, if you take Vm outside, so it will be Vm by pi outside. Then sin omega t integration, it will be minus cos omega t. So it will be, if you put the limit, so it will be altogether 2 Vm by pi. So just similar result we have obtained in the last class. You see, it is same thing. Yes, 2 Im by pi. Same thing. Where we have calculated the mean value of the half cycle. Mean value of the half cycle, here we are exactly doing that. Mean value of the half cycle, we are doing that. However, if we do the RMS value you need to should do a square, then take the RMS, then you take the mean value, that is the summation. You need to divide it by pi to get the RMS, to get the mean value, then you take the square root. So you see this Vm square, if you take it outside, it will be only Vm, and this, you see, this is sine square, so 2 sine square by 2. So this 2 pi you take outside, it will be root 2 pi. Then 2 sine square omega t, 2 sine square omega t, it will become 1 minus cos 2 omega t d omega t, integration from 0 to pi. Now cosine has 0 value because it is the average value. So sorry, it is not 0. Not 0 actually. Okay. So this part is 1 minus, this part is minus cos 2 omega t integration from 0 to pi. So if you integrate d omega t, it will be pi minus 0, and cosine 2 omega t, it will be sine 2 omega t by 2, limit pi to 0. The first component is pi. Now sine pi is 0. Sine pi is 0 and sine 0 is 0. So basically this will be 0. Sorry, sine this omega t, if you put pi, then sine 2 pi. 2 pi means 0, so it will be 0, and sine 0 is also so it will be 0. So it will be pi minus 0. It is okay as far as the result. So it will be Vm by root 2. The result is Vm by root 2. So the RMS value of this signal is Vm by root 2. So basically it is same as compared with this one. Compared with this one, it is same. Why? Yes, it is RMS value is same. Why? Because the reason being you are squaring it, right? You are first squaring it. Now the only difference is this: you are calculating for the previous case. You are doing or you are calculating the RMS value for this wave. Now for this one, you are doing the RMS value for this wave. Now after squaring it, it becomes this. Now after squaring, both the waves are same, so results are exactly same. So that is why the results are exactly same. Now the last waveform, we have a special kind of waveform that is normally encountered in power electronics courses. It is rectified version by SCR, where this alpha, this angle is called alpha. It is called firing angle. It is half rectified sine wave. Half rectified sine wave. So we can represent now this wave as Vm sine omega t. Now the existence of the wave starts from alpha and it ends at pi. From pi to 2 pi it does not exist, so it is not required to write. From pi to 2 pi it is not required to write. So what is the average value? So let me first integrate Vm sine omega t. Now what should be the limit? Limit should be from alpha to pi, because it starts with alpha and it ends at pi. Then you sum, then you divide it by the entire time duration, that is 1 by pi, not 2 pi, because pi to 2 pi it is 0 value, so you don't need to consider this time. So 1 by pi. So if you solve this, Vm by pi, take it outside, sine omega t integration minus cos omega t. Then if you put pi and alpha as a limit, then put omega t is equal to pi, so cos pi is equal to minus 1, and alpha, that is minus alpha, so minus alpha. So altogether it will be Vm by pi 1 plus cos alpha. So this is the result, very important result, the average value of half rectified sine wave with SCR 1 plus cos alpha. And similarly, we have RMS value. We need to first square it. Limit stays from alpha to pi. Then we take the average. Then we need to take the square root. So if you take Vm outside, so Vm by root 2 pi. So this sine square omega t, you need to multiply it by 2, divide it by 2. This 2 sine square omega t becomes 1 minus cos 2 omega t d omega t, that is written here. The limit becomes alpha to pi, and this 2 pi, if you take outside, it will become root 2 pi Vm by root 2 pi. Now if you integrate this, it will be first d omega t integration will be omega t, so put pi to alpha, it will give you pi minus alpha. And sine to omega t, cos to omega t integration sine to omega t. So if you put pi to alpha, so first term will be 0 because sine pi 0 minus sine alpha. So therefore Vrms should be Vm by root 2 pi. Now from there, if you take root pi common, then the entire thing will be given by this result. So this is the just an illustration. So what points needs to be remembered? in this course or in this module. First, that is a very important thing. The mean value is always 0 over a complete cycle. Mean value of a sinusoidal quantity or waveform over a complete cycle is always 0. The reason being, the positive half cycle is exactly equal to negative half cycle. Positive half cycle is exactly equal to negative half cycle. Due to this reason, RMS value is always considered for RMS value is always considered for measurement. Normally say that our household supply is 240 volt AC supply. 240 volt AC supply. 40 volt refers actually the RMS value. What is the relation between, very important relation, RMS and peak value? It is RMS, IRMS, that is peak value by root 2. Another thing, form factor is always 1.11 for a sinusoidal quantity. Now very important thing, phasor summation is not algebraic sum. That is shown in this example. It's not at all the normal algebraic sum, because these angles will be very influential factor. These angles, whatever be the angle, because this angle will be contributing to its summation, so it will totally change. So phase angle, that is why written phase angle must be considered. Phase angles must be considered to have the accurate result. And lastly, for a system of 50 Hertz, that means we in our country we have a supply frequency or power frequency as 50 Hertz. Our time period is always 20 millisecond. T is equal to 1 by F, that is 1 by 50. It will be 20 millisecond. It is always to be remembered. That is, for 50 Hertz system, time period is 20 millisecond. So we have seen the fundamentals of AC, and we have solved some problems, numerical problems, to give you the illustration of different things: RMS value, peak value, average value of different waveforms. And we have demonstrated also that phasor summation or phasor calculation is not same as that of algebraic calculation. So here the phase angle, that is the leading angle or lagging angle, plays a very important role. If you don't consider that angle, then your result will be totally wrong. Okay, so you must consider the angle as well as magnitude. Having said that, always remember that if you encounter some summation of the phasor, it is recommended to consider the Cartesian part, that is A plus JB form. On the other hand, if you encounter some product or division calculation, then it is recommended to have polar form, that is x angle theta. It will make your work easier. So with this, I am ending this session here. From the next session, we shall see the behavior of different parameter RLC or maybe RLC under sinusoidal excitation. What is the behavior of voltage, current and power. So thank you.